Hello, scholars. We are back again, and yes, we are talking about more amazing science. Science is so awesome. I grew up and I loved science. I loved it. I loved it. I loved it. I didn't even know I loved it, and I was loving it. Why? Because I grew up loving Kool-Aid. Now, if you've never heard of Kool-Aid, Kool-Aid would begin with a giant pitcher of water, much like this. It would be followed by a container of sugar, much like this, but the bag would be much more full because I'm gonna need to pump half of this bag into this water, and then I'm gonna stir it up as I add the red flavoring. Yes, red was my favorite, and then I'm gonna take it and I'm gonna drink it, and I'm gonna have that sweet, sweet taste run into my mouth, down my throat, and into my belly. I loved Kool-Aid. But why? Why was Kool-Aid such an awesome thing for me? Why? Why did I like it so much? Because I like sweet things. Yes, indeed. Now, where's the science? It was science because it was science that allowed that sweet, sweet sensation to be able to be put into the water and then into my belly with one word, one scientific word that we are talking about. This word is a special kind of mixture that we call a solution. Now, solution is another physical property that we can use to classify matter into groups. You can put a group over here of regular mixtures, like what we saw off in the bag right here. Or we could have a special kind of mixture, and those are all of the mixtures that when they are put together, they dissolve in water. Now remember, a mixture is two or more things put together. A normal mixture, when you put those things together, they are easily separatable. And then there is a special kind of mixture that we will be looking at today called a solution. Yes, and it's the solutions that I love. It's not a math problem solution, but it's a solution to the fact that Mr. Washington loves him some sugar. Yes, indeed. And it's not good for you. Brush your teeth and do all that kind of stuff, and don't do too much of it, but I like it. I really, really do. So, how does a solution work? We've talked about it previously, but we will talk about it again today. There's a couple of very, very common solutions that we have. Now, many of you might have seen this. This is a salt shaker. Salt shaker is full of salt. Now, when I look at salt, I can see that the salt is a solid. Let me get it closer to us. It's like right there. Do you see it? Do you see it? It's like right there in my finger. I can move it around. Salt. Describing salt. Salt is rough. It's grainy. It's a little sour taste, it's got that. And it's definitely a solid. But what we know about salt is that I've always wanted to use one of these little kits, like the little scientific test tube kits. This is called a test tube, and this is a test tube holder. So today we're going to be really scientific. I've always wanted to do this. So I'm going to take this test tube, I'm going to take this salt, and I'm actually going to pour it into my test tube. You can see all of it is in there. You can actually see the salt fall into the bottom. But now I'm going to take it and I'm going to see, is this a mixture or a solution? Or a special kind of mixture called a solution. Ooh, I got to watch that vocabulary. When I shake it up, I notice that if you look at there, all of my salt particles have dissolved. They have completely dissolved in the water. That means that this is a solution. But how? How can I prove that the salt is still there? How can I prove that this is a special kind of mixture called a solution? How can I prove that this salt has dissolved in this water? Where is my evidence? I don't know how I could ever prove it. What do you think? How could I prove that the salt is still there? How could I prove? What physical property of salt could I lean to be able to use as evidence to justify the fact that the salt is still in there? Think about it. Give me an answer. I want to know. Here we go. Pause. In case you want to pause the TV, pause. I know the answer. I know you know the answer. Some of you've probably already said it. One of the things about salt is salt has a unique taste. So if I was to take this and I was to grab it and I was to drink it, I'm not going to drink it. I have my thumb on it. I have my thumb on it. You don't drink scientific equipment. That's not safe. You can't do that. But if I did, or if I would have stuck it in a regular cup and been doing something like that, I would have been able to taste that the salt is still in the water. Yes, it's still there. And you know what? That is also what made my Kool-Aid so sweet, because I can do the exact same thing with sugar, except for I'm going to get a little bit more sugar because you know I like a lot of sugar. Once again, if we look at these sugar particles, the sugar particles look very similar to the salt particles, except for they seem like they're a little bit larger in size. They're still grainy, they're still white, they're still solids, they're still rough, and I can still take them. I'm going to use this one because I've used my first one. And I can pour them into the test tube. Okay, you can actually see them at the bottom right there. That's sugar particles in water. Now, I can take them, I can shake them, I can take them, hey, I can shake them, hey, I can take them, I can shake them, I can take them, I can shake them, I can take them. I know. I'll do music class later. I will do music later. Music and science, best friends, best friends. All right, so now if we look off in there, what do we notice? My sugar appears to have disappeared. No, I'm not a musician. I'm not a musician. No, I'm not a magician. I'm not a magician. I'm not a magician. I'm not a magician. What actually happened? You know what happened. The same thing that happened to our salt. Both salt and sugar are soluble. That means that they dissolve in water. They are soluble. S-O-U-L-B-E. Soluble. They dissolve in water. Now, we had other things that we had looked at that were not soluble, like the rocks that were in the water. The rocks did not dissolve. Those were insoluble. But these are soluble. Now, if I was to ask you to compare these two solutions, what would you say is similar about them? And what would you say might be different? What characteristics do they share? And what characteristics do they differ? Or where do they differ? Think about it. Told you some stuff about the salt. Told you some stuff about the sugar. Remember, a mixture is where two things are put together and they keep their physical properties. But a solution is a special kind of mixture where one dissolves in the other. And it's actually the solute dissolves in the solvent. And those are big old words that you'll probably use during middle school, but I'm going to give them to you now because you are amazing scientists. And water is also the universal solvent. Yes, it is. Scientists, that's what I want you to do. Your assignment, should you choose to accept it, explain to me between the salt water solution and the sugar water solution, how are they different and how are they alike? Have an absolutely wonderful, amazing science field day. You guys are awesome. I know you're awesome. I love science. You love science. Science is everywhere. Science helped my childhood. Y'all have an absolutely wonderful day, and we will be back on soon with more amazing science.